let's integrate cosine of the fourth x dx. So as is, there's no way we can integrate this. We have to reduce that power. So here's the best way to think about it. The cosine of the fourth power, would you buy, is the cosine squared squared? Sure it is. So one place to start then would be replacing that inner cosine squared with the first identity in red there. Cosine squared theta is 1 plus cosine 2 theta over 2. So that's where we're going to start. OK, so I do that. I get 1 plus cosine 2 theta all over 2. And then that whole thing squared.
Is it theta or x?
X is what I meant to say, yeah. Dx. In this case, theta is x. There's no need for that substitution, right? So we have to square that whole quantity, don't we? Yeah. Because all I have written right there is the cosine squared x in another form. Can you hold that thought?
Yes, I will hold it.
OK. And then we'll see if we can find another way of doing it. Don't drop it. OK. Now, when you square a fraction, what gets squared? The numerator and the denominator, right? So would it be too crazy if I wrote a 1/4 out front and just squared 1 plus cosine of 2x, the whole thing? That would be insane. Does everybody see where that 4 is coming from? The 1/4, rather? OK. Now, how do I square a quantity like that? So 1/4 times the integral, then square out this. OK, you square. There's two guys in here. Here's a guy, or a gal if you like, and here's a guy. So when you square a quantity like a plus b quantity squared, a the first guy, b the second guy, you square the first guy, but what happens when you square 1? You get 1. And then you add the first guy times the second guy doubled, right? 1 times cosine 2x doubled, 2 cosine 2x, right? And then the last guy squared. So the last guy is the cosine of 2x, so you have to square that. Cosine 2x squared.
So you still don't have a du.
Well, I'm not going for that yet. OK. Does everybody see what I did? OK. In fact, I might get this to a form where I don't have to do a U substitution. But we need to talk about something else first. There's a problem here.
You still have cosines?
Well, cosines are good, because I know how to integrate cosine to the first power.
Yeah.
But one of them is not cosine to the first power.
No,
Cosine squared. But I can do it again, right? But now what does the identity become for the cosine squared when the angle, if you think of it as an angle, is 2x? It becomes 1 plus cosine to the, or cosine of, I should say. You double it, right? I mean, that's what the original identity says. The original identity says you take whatever is here, call it theta or whatever you want to call it, and then what goes here is whatever that is doubled. So if it were 2x to start with, you double it, you get 4x here, right? Everybody see that? So long story short, I can replace cosine squared 2x with 1 plus cosine of 4x all over 2. OK, so that means in the next step, before I try to integrate anything, I'm going to replace this last guy with this guy. OK, so I have, what do I have? I have 1 plus 2 cosine 2x. Those guys are good to integrate, actually. And then this whole thing becomes plus. Could I split this up and make it like 1/2 plus 1/2 cosine of 4x? Is that the same thing? Yeah, so I'm going to do that. So 1/2 plus 1/2 cosine of 4x dx. Notice the parentheses around the entire integrand. OK, everybody see what I did there? All right. We do have kind of like terms, don't we? Not kind of, but they are like terms. 1 and 1/2. Let's get those two lovebirds together. Yeah, it's 1 1/2, but how do we want to write it? 3/2. So we have 3/2 plus 2 cosine 2x plus the 1/2 cosine 4x dx. Did I forget anything? Everything looks good. Okay, we're ready to integrate, believe it or not. Now I'm going to show you a trick on avoiding U substitution here, although technically to verify what I have written, to verify what I'm about to write, you'd have to use U substitution. All right, so let's leave the 1/4 on the outside, bracket. Okay, integrate term by term. What's the integral of 3/2 with respect to x? 3/2 x. Now, this 2 cosine 2x, okay, technically, if you want to see what I'm about to write down, if you want to see where it comes from, you could let u equal 2x. And then du is just what? 2 dx. So U substitution would definitely work here. But this one's worth memorizing. Okay, it comes up so often. When the argument on a trig function or like an exponential function, when the exponent is like 2x or something times whatever the variable is, then when you integrate it, okay, first of all, this 2 is here to begin with. You just multiply out front by 1 over. You're basically reversing the chain rule when you're using U substitution. So we're dividing instead of multiplying. So multiply out in front by 1/2, which is the same as dividing by 2. And so we get 1/2 out in front. And then what's the integral of the cosine? Sine. So it'll be sine 2x. Now, so what did I just write down? This is the antiderivative. This thing that I boxed is the antiderivative of the cosine of 2x. Do you believe that? Take its derivative if you don't believe it. The derivative of the sine of 2x is 2 cosine 2x by chain rule, right? That extra factor of 2 by chain rule. Times that 1/2, you get the cosine of 2x back again. So it's got to be right. And then with this extra factor of 2 out here, of course, we're going to get some cancellation there. Now, use the same trick on this one. When you integrate, what are you going to have out in front? You just multiply by the reciprocal of whatever is in front of the x there. So it's going to be 1/4 times the integral of the cosine is sine, and the argument's 4x, so leave it 4x. And then at some point, put in a plus c. It could be now or in the next step. Does everybody believe that? Okay. Now that works for like if you had e to the 2x. What would the integral of e to the 2x be then? 1/2 e to the 2x. How do you see that? The easiest way is to reverse it by taking the derivative and getting back where you started. Okay? Well, we should simplify a little bit. I don't care about multiplying out the 1/4. But inside we get 3/2 x, what, plus sine 2x. Oh, what about an 1/8? Yeah. What about this? 2 times 4? Yeah, so 1/8. And then I'm not even gonna multiply out that 1/4. You could if you wanted to, or you could factor out something if you wanted to. But I'm gonna leave the answer like that.